Monday night, so it is the Physicist and Philosopher Hour.
Mhm.
And our physicist, Dr. Claudia Albers, how are you?
I'm very well, thank you, Wayne. And how are
Good.
you?
I'm doing well, thank you.
That's
We, just to let everyone know, we have some um, heavy thunderstorms taking place.
oh,
So if you hear anything in the background, just know it's just nature's way.
mm-hmm.
So we've had a lot of very hot weather here. Claudia, as you and I have talked, and you and I were right before we were coming on, that the middle part of the United States is experiencing something that has never been recorded before. And that is that we have the polar jet stream, and that's where it's originating from, going directly due south from north.
Mm-hmm. Yeah,
That's pretty
yeah.
odd.
And I've been observing that even during the winter months, it was coming far down. And I still think that what's occurring is the Arctic Ocean is warming up. The Earth's oceans are warming up much more than the land masses. So when the Arctic Ocean warms up, it pushes the polar vortexes downwards over the land masses, so over Siberia and over North America. So you get a split in the polar vortex. It goes over the land masses. At the moment, we're seeing Greenland is much colder than the Arctic. And that's because Greenland is a landmass. There's no ocean there. Whilst where the ocean is, it's warmer because the oceans are warming up. So that would cause that pushes the vortex down over the land masses, and then the jet stream has to go around that.
Well, I want to give a shout out to this young man. He's a high school student
Mm-hmm.
on this website. It's Ice Age 2050. I believe that this young man is onto something. He goes by the name the Climate Guy.
Uh-huh.
And Claudia, very impressive. He has been doing research of his own. As he says, I'm a high school student studying weather and climatology. I am aspiring to become a meteorologist and a climatologist and obtain a PhD. My mission is to educate people about the climate science and clarify the misconceptions that we hear from the media and politicians. And what he is postulating here is that we are not in the midst of global warming. We have now entered into the new ice age. And his research is showing that, and of course, please go out there and check it out for yourselves. I was very impressed with what he is showing, that everything is pointing to a climate change that shows everything to become colder, not hotter.
Yeah. The thing is, the land masses, like I said, are cooling down in places.
Mm-hmm.
But the data is actually very complex. You have to realize that, I mean, if you look at the maps, you will see that most of the Earth is warming up, especially at the poles, the North and the South poles. The land masses are cooling down in places, but other land masses are experiencing temperatures that we've never seen before. India,
Yes.
50 degrees. Australia experiences now temperatures of 50 degrees. 20 years ago, we would think it was impossible for anywhere on Earth to have temperatures like that.
Nope.
So people are saying there's an ice age, but the thing is, it's only getting colder in certain places during the winter, and it's Siberia and North America. And it's like I said, it's because the polar vortex is splitting and moving over the land masses. But the ocean stays warm, the Arctic Ocean. And you have to understand what is causing all this. And the data shows that all the planets in the solar system started warming up many years ago. whole planets have started warming up. All the planets have experienced climate change. And that could only be because something changed in the solar system, not just on our planet. Apparently, Mars is having the storm at the moment that's supposed to have ended already, but it's not ending. That means it's something that Mars doesn't usually experience, or beyond, going to another level as well.
Well, this is all I have to say is please go to his website. He is not alone in his research. I think that in the midst of getting climatology data, I think keeping an open mind in all aspects of all theories, he is not alone. He cites a great deal. I just want to give this young man that if this is the type of students that are being coming up, then there is hope for humanity, because you have to admire a young man who's already setting out his goals for his professional life and where he wants to go. So anyway, I just thought that was remarkable. I applaud young people who have already taken the commitment to saying, I know for the next 10 years is going to be dedicated to my study. And that's commitment. So anyway, just wanted to point that out. I thought that was kind of interesting. Now, Claudia, I captured something over actually it was Friday, and I thought that you might like to see this. So let me, as he fumbles here. Let's see, I have to stop the share there. This is like driving a, so there you go. We had, this was Saturday. We had the most unusual sunset. And I thought that you would like to see this.
Wow, it doesn't look normal, does it?
Does not. I had my cameras going, and I love the fact that you can just see above the clouds here, you can actually see how the sun is, I don't know, casting a, there you go. That brings it out even more. Pretty interesting, isn't it?
Yes, it's interesting that the sun is actually illuminating clouds behind it.
Well, I just took the picture.
How is that possible? Well, the sun is supposed to be 93 million miles away, and yet these clouds seem to be behind the sun. Look at it.
It's amazing.
You can actually see the edge of the sun that seems to be in front of those clouds. And this is because they're using holographic projections for the objects we're supposed to see in the sky. And I don't know if you've heard that somewhere in Siberia, the sun suddenly went dark. I mean, it went from night to day, from one moment to the next, and stayed night for 3 hours. And then the sun started working again.
Odd that you mentioned that. Someone sent me a link to a commercial. Here's another view of this. Now, this is what I thought was so interesting. As you can see, look at the clouds behind here. I don't know what happened here.
Yeah, this is definitely clouds behind what appears to be the sun, but that's not the sun. It's the simulator or the holographic projections that they do. I've written some articles where I actually show photographs of an airplane flying right through the sun. It actually pulls out some of this cloud-like matter that it seems to be made of. And you could see what it is. It's a holographic projection in the clouds themselves. A three-dimensional projection. It's a holographic projection. So I think what they're doing, they're using the simulator that's in orbit, that device there, and somehow they're using a kind of laser projection onto clouds that then makes it look like the sun. Then they have a lens system in front of it. So that looks like, and this is the one they usually use close to sunset.
Well, what's odd about this picture here, this is my Canon that I took this picture with. And look what happened to the pixelization. Two things that you can see here, there's a light shift here, but look what happens to the sun here. It's pixelating out. Let me get back here. Here we go. Look at this. Look at here.
Yeah, look at that.
And it's really odd because this camera, again, you can see the clouds are behind the sun.
Definitely. You can definitely see that. This is definitely tells you what we are seeing here. It's not the real sun. It cannot be the real sun. The real sun cannot be in front of clouds.
Here's another one. If people, you can take a look for it yourself.
And this is not just happening with the sun. Some people are noticing it happening with the moon, because the moon is a holographic projection as well. Because, and this is also why it suddenly went dark in northern Russia. It was in the Arctic Circle. They're supposed to have 24 hours of daylight at the moment. The sun suddenly disappeared. And then they're saying it may be pollution, but if it's pollution, you would see a cloud come over. Someone would have seen the cloud come over. No one saw anything. The sun suddenly went dark. Yeah, so you have the moon there.
And this is Venus.
Uh-huh. And I don't think it's just the moon anymore. I think the planets. I was watching one of these videos by Boogeyman, and he was showing Jupiter. And he was showing how Jupiter turns into a horseshoe. All of them, I think all the planets have to be holographic projections now, because you see, if the sun goes dark, and I've shown that it does go dark, then you wouldn't see the planets because we only see them when they're reflecting light.
Or so they say.
Yeah, I mean,
I'm just kidding there, Claudia. I'm just adding with a little humor to that. But so I just, like I said, I captured that right here in Colorado.
Yeah.
It was, you could see it coming in. And I told my wife, I said, honey, I just want to say hello to all of the moderators. Thanks everyone else who's stopping in. We appreciate that. I said, hon, have you ever seen a purple magenta sun? And of course, she says, well, not in this lifetime. And I said, come here. So, and granted, for full disclosure, yes, there was a lot of smoke in the area. But that, I think, is an interesting thing, because if the smoke is coming in, smoke is particles, ash, basically. It's, and it does crazy things, as you know, with objects. And I think in this case, I think we actually showed something was amiss.
Definitely. I mean, the magenta color is not normal either, as you said.
Not on this planet.
Because in order for the sun to be magenta, it's usually red at sunset. It cannot be magenta, because magenta would mean that you have red and blue mixed together. But what happens at sunset is all the blues removed out of sunlight.
Yes.
And then you left with green, and then eventually the green starts being removed, and then you left with red. But in order for it to be magenta, it has to have the blue, which would have been removed first.
One would think.
Yeah, so that's not possible. Just not possible. But we know it cannot be the sun anyway. And so
yes.
I don't know what they're doing, but they're obviously causing it to emit different colors. Or the magenta sometimes is due to ionization. So they may be using a gas that ionizes and emits pink light.
I am looking for something, Claudia, because I want to show you what is happening in commercials. When you started talking about the sun blinking, there was a lot of pushback on that, and people kind of just said, well, and give me 1 second here. I'm trying to find this. There is a solar company in England that has actually got that commercial in it where the sun is literally flashing.
Yeah, well, we see the sun flashing all over the place nowadays.
Mm-hmm. We do.
But what happened in Russia was very interesting, because afterwards they saw all this black dust on the ground.
Really?
Yes. So what I think may have happened is a whole lot of dust, stellar core dust, came in, and it most likely interfered with the sun simulator or the sun simulation system, and that's why it malfunctioned.
Now, I hope I don't get in trouble for this. If we do, well, we just do. So here
playing an ad, do you think you would have a copyright problem with that?
I don't
because
think so.
Basically you're giving them what they really want, which is people to see it.
So I want to pull this up, and let me pull this out, and folks, let it play for what it is. I got the sound turned down. That's the sun doing that.
Mm-hmm.
Now watch what happens here, Claudia. This is the key part. Watch this. Did you see this? The sun, yes. 170 quadrillion watts.
Yes. In other words, they're saying it's artificial.
It's a simulator.
Yeah.
This one malfunctioned. Now it's going to go dark. There we go, 174 quadrillion watts.
And they're going to replace it.
So anyway, folks.
So basically, this is the truth, Wayne. This is the truth, because the sun is malfunctioning because it's a device. It's not the real thing. So they're telling us the truth.
And here's what I know. I spent 2 decades in advertising, so I know what I speak of here. Folks, this is probably one of the strongest subliminal suggestions I have ever come across. And I found it odd, Claudia, 2 things. Number one, the sun blinking.
Mm-hmm.
People just say, well, that's impossible. How do we know that? 2, they actually had a simulator. 174 quadrillion watts. How interesting that, and there we go. So I think that was very strong messaging.
Well, basically, this is what we have on Earth. Basically, our real sun is not working like it should be. Because as I said, from the beginning, I showed that the sun goes dark, so it blinks in and out. And the other thing is we have these huge stellar cores in the solar system that are very close to the sun, and they are eclipsing the sun. You know what will happen when a huge object larger than the sun goes in front of the sun? The Earth will be plunged into darkness. And not only the Earth, whatever other planets or in that direction will be plunged into darkness. Jupiter would disappear because what we see is reflected light from the sun coming off Jupiter. So if there's no sun, we wouldn't see any planets. We wouldn't see the moon. Nothing. Everything would disappear. Everything will be pitch black. The only thing we would see is the actual stars, because the stars are light sources. But the planets would disappear.
You know what? That almost sounds like the theory of nothingness.
Mm.
Mm-hmm. I did a video on that this week that Claudia just...
Okay.
It invoked a lot of, how should we say, a serious chord in a lot of people. But you are correct. And I often wonder when you talk about Jupiter, it was just released here over the weekend, another 29 moons discovered around Jupiter.
Yeah.
What the hell is going on? I mean, does Jupiter have this vacuum cleaner out there? It's the question I have, Claudia, is this: where did all of this debris come from? I mean, are we in a debris field? Have we been in a debris field?
We have.
Yeah. Okay. You want to expound on that?
For the last 200 years, basically. That's where the stellar cores are coming from. Our solar system entered an area of our galaxy where there was all this dust. When they say we're in a dust cloud, we are in a dust cloud. The dust comes from the stellar cores. They shed their outer layers as they expand. As they expand, their surfaces breaks up. And they shed all that material. So, of course, where they are is filled with dust and debris. And our solar system entered that region, and the stellar cores and that dust started coming into our solar system about 200 years ago. So, what do we expect?
Well, because what we've been taught is that we live in a very tranquil, very predictable universe, but particularly our solar system. Scientists, others are ridicule when they go outside of the thought that we live in this very predictable plane of orbits and the planets are just doing their dance.
Yeah.
Obviously, where they're not.
That's the thing. We've been lied to just about everything. Everything we've been told. That picture you showed last time about the center of the galaxy.
Yes, sir.
This is what this article is all about. What do astrophysicists see in it? They see, oh, there must be a black hole there. We don't see anything to do with a black hole. We just see gas. Oh, we see these filaments, but we don't know what they are. Well,
there it is.
So what did I do? I looked at it, I thought about it, I used what the stellar cores had taught me, well, what God had shown me as well. I don't know. Regarding what the stellar cores do and what I've observed. So let's look at that. What do they see? They see a black hole. Do you see a black hole there?
No, I do not.
Any region where material seems to be sucked into a black hole. But that's what they see. They see a black hole there. I don't see a black hole. I see gas. I see these filaments, which must be due to ejections. Why would you get a filament? A filament is not pulling material in. If it was pulling material in, you would see the material starting to circulate and move inwards towards something. We don't see that. We see gas that has to have come from the center. You have to realize this is about 1,000 light years. A galactic nucleus is less than 1 light year across. It's very small. In active galaxies, and I explained that active galaxies, which are very bright, have to be young galaxies. Because what the stellar cores have taught me is that energy is associated with gravity. So young objects, of course, are more energetic. They have more energy. Energy is used up as they age. That's logical, isn't it? So very bright objects are very energetic. That's logical as well. If you see a very strong light bulb, don't you think that's one that's putting out a lot of energy and using a lot of energy in order to be bright? That's logical. Mm-hmm. So a very bright galaxy is a very energetic galaxy. And the very energetic galaxies have nuclei, active nuclei that are about 100 AU across. That's the size of the solar system.
Yeah, and again, I still contend that I don't think we have yet to discover everything of the universe, and that, again, I'm just mystified how these these are galaxies, right? These, I mean, these
They're not galaxies. Let's
these are
go back to
stars.
the first image, Wayne, and I'll show you what they are.
Where did we go up here?
Let's go back to that first one. This is an artist's impression of what our galaxy looks like.
Yes, an artist impression.
Well, of course, we cannot look at it from outside, but over the years, with the observations that have been made, we know what is out there in different directions. We know there are these globular clusters that seem to be orbiting the galaxy. That's what these lights are outside the galaxy. We see the bulge, the central bulge, which is much brighter than the rest of the galaxy. And above and below the bulge, we see these circles of light. These are actually globular clusters. These are clusters of stars, and they're very compact. So the stars are very close together, especially at the center. And there's a picture down there where you see what a globular cluster looks like. That's what it looks like. So it's a compact collection of stars. And what the stellar cores have shown me explains what is occurring. These are ejections from the galaxy. The galaxy is ejecting globules of matter, which condenses into single stars. And at the beginning, they're very close together because they're very energetic at the beginning. So they're high in gravity. So they're pulling in all the matter in, as if they were grains of sand, but attracted towards the center. And then as they age, the stars move outwards. So then the cluster is not as compact.
Now,
so that's what those globules are. Those
we're talking about right here
are globular clusters of stars that have been ejected from the galaxy and are in a formation stage. They starting to condense into single stars. This goes along with what Holton Harp showed, that active galactic nuclei, the most energetic galaxies, are ejecting huge amounts of material that then condense into quasars, which then turn into galaxies. But our galaxy is not as active or as young as active galaxies. Our galaxy is older, so it's not as bright, so it doesn't eject these large amounts of material. It ejects smaller ones, which turn into star clusters instead of other galaxies.
We live in an amazing time.
So you see, everything that the stellar cores have shown me, I can use to tell you what this image is all about. What are all these filaments? These filaments are due to ejections. Ejections mean that it comes from something that's already condensed, already has a core in it. And you don't expect the matter that's coming from the galactic nucleus to have condensed in this region. It probably has to move outwards before it condenses. Those spherical structures have not condensed yet. They're in the beginning of their formation stage. But yet we see ejections coming not just from one point, but from several points. That's why we have filaments all over the place. So what does that suggest? Is that there isn't just one galactic nucleus. There are several. And what I think has happened is that as the galactic nucleus aged, as the galaxy aged, the one galactic nucleus expanded in size and fissioned. It broke into several pieces. So there are several pieces of the original galactic nucleus at several different points, and they're all doing their own ejections.
Well, then that's counterintuitive to what the theory of a black hole. I don't, for me, I look at this and I have a sense that there is something intensely spinning here. It's just me, but
well, what is happening, and what I explain is that the original and the strongest galactic nucleus is right at the center of that. And what you see, that thing curling like that, that's an ejection, a very strong, very bright ejection that's occurring whilst this photograph's taking place. Of course, this was occurring 28,000 years ago.
Billion years ago, right?
No, 28,000, because that's how far the sun is from the center of the galaxy. So this occurred about 28,000 years ago. But so the light is just getting to that came from this, is just getting to the sun now. But this is what we're seeing. We're seeing that this ejection going on right now, this huge amount of very bright plasma doing this, being ejected from that region. And then on the other side, this globule that's also very bright, that's also plasma that's being ejected out of that point. There is no black hole there. The stellar cores have shown us that black holes cannot happen because stars have cores in them, solid cores. A black hole would require gravitational collapse towards the center, but a dense solid core cannot collapse gravitationally. Also, some of these objects are so huge that if gravitational collapse had occurred, they would have collapsed into black holes. But the opposite is happening. They expand as they get older because gravity is associated with energy. So as they get older, they lose energy. So instead of gravity increasing and them collapsing, they are expanding outwards. It's the opposite of what we've been told. That's why there's no black holes at the center of galaxies, because black holes do not exist. If black holes existed, we wouldn't have these stellar cores in the solar system. That's why they don't want us to look at the sun and what's happening there, because it changes everything when you realize that these objects, these stellar cores exist.
Well, the picture does seem to defy, I think, what has been typically the standard model. Again, it's a fascinating picture.
Now, you see, to them, it doesn't defy their model, but it means that they don't know what's going on in this picture. They cannot explain it because they would have to change their theory in order to be able to explain what those filaments are. But the fact that using the theory that I came up with, I can explain what those are in a self-consistent way. Logically, I can explain what this image means and what's there. And astrophysicists cannot, because they have not accepted the fact that our sun does not work in the way the theories tells them, and other stars do not work. And we can see it all because the stellar cores have come into the solar system and we can observe them. But they will deny it that they even exist because it will change everything.
Well, I can tell you as an observer of humanity that we are in an era of change. Everything is being turned upside down. I think that even our logic of what we thought things were going to become changes as well. If there's something that cuts off, just be patient. It's very, very lots of thunderstorms going on. In fact, I can see the lightning out there. So, you know, Dr. Albers, when I see this and I hear you, to me, you know, I happen to think that there is sound logic in what you're saying. And so...
Yeah, I mean, I was actually surprised. I mean, when you showed me this picture last week, I looked at it and I thought, wow, it looks interesting. And I started seeing those circular things and I would say, well, they would have to be star clusters. I didn't realize, I needed to think about it carefully. But when I started thinking about it, knowing what I know regarding the theory that I put together, which is all based on observation of the stellar cores and the interaction with the sun, I started to see what was really going on in this image. And I discovered something very interesting. I never expected for my logic to get to the point where, but wait a minute, that means that the galactic nucleus has actually broken up into pieces. That's the only way that this could be explained, what we are seeing, these filaments coming from everywhere.
So let's go back. If the breaking up into pieces, if the galactic, what does that entail? I mean, wouldn't that then say that the very Milky Way itself is breaking up from the middle out?
Yeah, not necessarily, because in the beginning, there was one galactic nucleus. And when galaxies are young, they're very bright. And the galactic nucleus is very tiny. It's only 100 AU. Remember, 1 light year is 63,000 AUs.
No, wait, one AU is 93 million miles, right?
It's 93 million. The size of our solar system is 100 AU. So when you have a very young galaxy, the galactic nucleus is only the size of the solar system, about 100 AU, sometimes even less. Okay. That is extremely tiny. That's 1 divided by 63 of 1 light year. And what we're seeing here is 1,000 light years horizontally across.
Which 1 light year is 6 trillion miles, which is, you know, big.
It's huge. Distance. Okay.
So our solar system is roughly then 93 billion miles in the radius.
Our solar system is
that would be
9,300. So it's 93 million times 100. So that's 9,300 million miles in radius.
Okay. So 100 AU.
So it's 100 AU. Notice the distance between the sun and the earth is 1 AU. The size of the solar system is 100. This would be the size of a galactic nucleus when it's new. If you look at that there, the galaxy is 100,000 light years in diameter. Right. So the galactic nucleus, even if it's just 1 light year, which is much, much larger than it would have been when it was, when our galaxy was young. Okay. So it would have to go from 100 to 63,000. So you would have to multiply by 630.
So 28,000 light years between where we are to the galactic core. That's a long ways out there.
Yeah, it is a long distance from where we are. But you have to realize that the galactic nucleus is just a tiny, tiny speck. When it's young, it's about the same size of our solar system. So it will be just a speck there.
Yeah, speck being relative in one's perception.
It's still a speck in comparison to the size that we have there, which is 100,000 light years. Tiny speck, we wouldn't really see it at all. It's so tiny. So when a galaxy gets older, then the brightness of the nucleus goes down. It's not as bright. That means it's not as energetic. That means it would expand in size. It would get larger. But I never expected it to actually be broken up into pieces. But the fact that we have light coming from different points, I mean, ejections coming from different points, that means that the galactic nucleus would have to be at all those points. And the only way that's possible is if it's broken up into pieces. But you would expect that sometimes to occur to an object that greatly expands in size. It would break up into pieces. Also, what you see in the globular clusters is they just plasma there. They will condense into single stars. It's like one huge big plasma ball turns into 100,000 stars. It's also
when I see this, Claudia, I still wonder on the principles of gravity, because here I'm seeing what would not make sense. I mean, obviously, you would think that this larger mass would have a greater mass of gravity to it, but yet, then we see, as you said, these globular clusters here, which is obviously gravity at play. And it just always amazes me that gravity is one of those things that I never find it constant. It's there, but I can never find the consistency.
The gravity we've been taught about is gravity that only attracts. It only pulls matter in, but gravity is not like that. There are two parts to gravity. There's a part that attracts and there's a part that repels. There are two parts to it. It's like electricity.
That's magnetic, isn't it?
And magnetism, yes, because magnetism is part of the electrical, it's part of what charge does. So it's part of the electrical part of the universe. So there are two possibilities in gravity, like with magnetism. It can attract and it can repel. That's what causes objects to eject matter outwards. It's the repelling part of gravity that causes that. That's why everything in the universe is, out of the energy that it has, is creating more matter. Matter's coming out of it. That's why the sun has a solar wind. It's caused by the sun ejecting matter. That's why they are CMEs. The sun ejects matter. Every other object in the universe does the same thing.
So go ahead. I'm sorry.
Sorry, if you want to ask something.
Yeah, it's like I can, when you explain that, I get the idea of the experiment. It's like everyone's on the merry-go-round. And as the rotation increases, one would think that you would see gravity, which would compel and attract. But actually, if you're not anchored, you're going to be flung out. And it's that, what I've often seen is the conundrum of when you see it actually in motion. Now, are we seeing down here is, of course, so it's all speculation at this point, but I'm wondering if these, as they continue to move outward, will become within themselves their own globular clusters.
Yeah, what we see there, you see some small structures there that look spherical. That, I think, are globular clusters that are in the course of forming already, but they still within the plasma cloud that's been ejected from one of the parts of this galactic nucleus. So this plasma is being ejected out. Remember, the sun does the same thing. That's why there's a solar wind, is plasma being ejected out from the sun. So
you would go ahead.
So you would expect the galactic nucleus to operate in exactly the same way. There's ejection. This is why atoms emit light, because photons are emitted out of atoms. What we see in the microscopic, photons coming out of atoms, we see in the macroscopic. Stars emit light and plasma. And so galactic nuclei will do the same thing. A galaxy is made up of the plasma that the galactic nucleus has ejected. And it starts out as plasma and it condenses into matter. Alton Harp detailed all this in his book, Seeing Red.
Yeah, actually, I had that right over here on my desk right now.
Yeah, he saw that happening from the active galaxies, how they eject material which condenses into quasars and then turn into galaxies. And now we are seeing this from our galaxy, except our galaxy is not an active galaxy because it's no longer a young galaxy, it's an older galaxy. It's not as bright as active galaxies. So it doesn't eject quasars, it ejects globular clusters. And then the globular clusters that go above and below the plane would tend to orbit around. Probably most of them are along the plane. of the galaxy, and those would turn into the stars that make up the arms of the galaxy.
Well, I think that as we continue to reach out there, Claudia, we'll learn more. I mean, I keep on thinking that we don't have any idea of the speed, but it has to be massive speed
They would
being
be
reached here.
moving at the fastest when they leave the point of ejection, and they would slow down with time. And Alton Harp also saw that. He saw the objects moving close to the speed of light initially, and then slowing down as matter formed, as matter appeared. And he could see that that condensing of matter and galaxies forming. And the redshift has to do with how young matter is. When it's very young, then the redshift is very high. And when it ages, the redshift is not as high. That's why young galaxies and quasars have very high redshifts, and older galaxies have lower redshifts. It has to do with the age of the matter.
So, folks, we're all a bunch of old people. We're in an old system, unless you go with the one theory that we originally started out with, the Sagittarius dwarf ecliptical galaxy. And as I keep telling people, we're still in the midst of that collision. That's one thing about our galaxy, is that we seem to be a carnivorous galaxy. We like to eat up the smaller ones.
Except that most of the time when astronomers say there's a collision going on, the opposite is actually occurring. It's an ejection. So most likely the Sagittarius galaxy, I'm not saying that it's not possible that they are collisions, but what we're seeing in the universe is white holes where they say they are black holes. So instead of matter coming in, matter's going out. So you would expect perhaps the Sagittarius galaxy actually came from our galaxy a long time ago, and it's still in the process of moving outwards.
See? That's the thing. It's a conundrum. Thank you, Money Jones. Appreciate it. We try to bring education, because a lot of times when I'm sitting here, I am the proverbial hamster on the wheel going, okay. It's a lot of what I think that people are dealing with today, Claudia, is that the science is coming so fast that old perceptions and theories are being disproven. New ones are coming in and replacing that. And people sometimes have a problem breaking away from the old to accept the new.
Yeah, you see, what happened with physics is, and this what I discovered for myself when I found out that my own field was totally wrong, which is particle physics. Now,
that's heresy, right?
Yeah, exactly. Now,
Okay.
I first found out that astronomy was wrong because I knew the Big Bang model couldn't have occurred. And then, but I thought, no, but there's nothing wrong with my field. It's particle physics, everything's fine. Then I discovered everything's wrong with it as well. But you see, what happened with physics was, until the beginning of the 20th century, physicists still thought we should simplify things as much as possible. If a simple theory works to explain what we are seeing, and they were still departing from observations, then that's the best thing to do. But about the beginning of the 20th century, it suddenly became fashionable to make your theory as complex as possible. The mathematics had to be beyond everybody else's understanding, and then it was a good theory. And that was the opposite of what had been done until then.
That sounds like chaos.
Exactly. This is what happened. This is why people in different fields do not even understand each other's work properly, because the mathematics is beyond them. But they're still trying to make it as complex as possible, because then they feel good, because now no one else can understand what I'm saying. Only I can understand it. And so this is the greatest theory on earth. This is what's going on.
If that's not the epitome of intellectual elitism, I don't know what is. I mean, and it's preposterous that you're right, that your discipline, your field that you've devoted your life to is and I'll just say this, is like a mirage. I know I'm on a desert, but damn it, I'm telling you, I see a lake out there. And observation would then allow me to postulate the standard theory of everything based upon the fact that I saw that mirage, and I'm going to tell you, I'm going to prove to you by my math that it really does exist.
Mm-hmm. Yeah, the thing is, they threw out observation completely. If they hadn't thrown out observation, they would have taken what Halton Arp showed, which is so detailed, so well done in his book Seeing Red, that no astronomer should continue to believe in the Big Bang model. But they continue to do so like it's religion. And they continue to build their theories on mathematics detached from observation.
It is a religion.
The biggest theory in theoretical physics right now, and has been for years, is string theory.
Yes.
Now, I delved in string theory a little bit. I actually thought at a time I may actually go into it. And it's not that I don't like the mathematics myself, but there's no connection with reality. It's mathematics, it's not physics. And most of the theories nowadays, most of quantum mechanics, is not based on reality. It's based on mathematical fairy tales.
That's a heavy indictment.
And I'm a theoretical physicist. And I love the math. I love playing with math. Don't forget, as a student, my biggest thing was going home and spending hours solving an integral. I love doing it.
Claudia, you lived a very boring
physics. Life. It's mathematics.
No.
The mathematics should serve observation. It should help you to figure out what the observation is telling you. But they started worshiping the mathematics and detached it from observation.
Yeah, and now observation is ridiculed as being subjective to the one viewing, not the one actually explaining. And I get that. It's hard then for the layman who is attempting to make sense of this, is why it's almost an impossible task, because your profession makes it impossible to understand.
Yeah, this is why every paper I write is based on observation. This is why I like to use the images, because I say, this image shows this. It's still a logical progression, but instead of mathematics, and I do use a little bit of mathematics now and then when it serves my purpose, but I try to keep it simple because I know my audience are not trained physicists most of the time. But I use the images, the observation, as an aid to my logical deductions. And if an image comes about that refutes what I have built my theory on, then I would have to change it. But the theory is based on observation, what I have seen these objects do as they interact with the sun.
Interesting. By the way, Claudia, I'm making some arrangements now to go up to Boulder and actually go to the facility that processes all the Secchi photos.
Very interesting.
Yeah. They also process all SDO. In fact, as I'm finding out, Boulder, Colorado is the spot where most of the space analysis is taking place. So I will let you know. I want to once and for all.
You know that NASA has a live feed from SDO.
They do? Now, I know I can get the delayed ones, but if they have a live one, I like to see
They have a live feed. I don't think they, because I was listening to one of the astrophysicists talking about brown dwarfs, and they were complaining that they don't get the data that NASA has, which is a live feed.
Okay.
Because they don't let anybody see the live feed. And I doubt that even the people that are processing it have access to it.
Yeah,
They will hand out what they want to hand out, and that's it.
yeah, you have to go through the PI, that's the public information officer. But yeah, it's going to be curious because I'd like to get maybe a little bit more of a different perspective as to why did they shut down Stereo B? Why is that gone? When I have heard, and I don't know about this, but I've heard that they're still getting radio signals from B.
Yeah, but they will only tell you the story they've come up with, that, and it's an involved story. They obviously wrote a good script for that story, and I don't think they're going to change that story. That it Stereo B,
maybe right.
Yeah. Okay.
Yeah, I think you're right. I mean, I still contend when we started getting the first pictures from that in December of 2006, I think it absolutely freaked those guys out going, what are we seeing here?
Yeah, especially the huge comet.
Oh, yeah. Yeah. And particularly what I considered the first time, the object that is out there. I don't know what you want to call it, but I know that there is something out there, and I don't think.
Well, we know there are several out there already.
Yeah.
In an image from 2001, which is a Hinode image. You can see it's an object that it's emitting X-rays because it's an X-ray image.
Yeah.
And you can actually see details of the surface of the object, like it has a band raised above the rest of the surface along what seems to be the equator. And, the trolls will always tell you, oh, that's the moon. Excuse me, but the moon does not emit X-rays. The moon scatters X-rays, and you'll never be able to see any details of the surface of the moon from scattered X-rays.
Well, now, damn it, that's heresy again.
So it's definitely a stellar core that was in one of the last images emitted by Hinode.
That's interesting. Yeah, I want to go back and look at that. And again, I just go back to, well, thank you, Claudia J. The one that I keep on seeing is what people tried to say was just merely a ghost image of the sun. And that's been proven to be erroneous. So there is something out there. It seems to have pretty much a predictable orbit now from what
well, I don't think these objects would have a predictable orbit for long.
Mm-hmm.
They will stay in that orbit possibly for a while, and then they come into the corona and they attach to the sun, they drain energy, they move out again. I don't actually know where they go. It could be when they are ejected, they go out throughout the whole solar system, and then they come back to the sun, or they get captured by one of the planets. This is the reason why Jupiter has so many moons, because it's been capturing these stellar cores.
Yes. Well, there you go again. So where's this debris coming from? I mean, it doesn't make sense to me as to how's Jupiter picking all this up?
Well, it has to be coming from outside the solar system.
One would think.
I mean, where else is it coming from? It suddenly, the sun is sprouting new planets and moons? No.
Oh, there we go again. They're not going to like that one at all. And I'm actually trying to pull up some file footage here, Claudia, so we could actually take a look of what the last of what B gave us before they took it down. And so that's what I'm actually doing. Not that I'm ignoring you.
No, that's fine.
Just it's there.
Yeah, I must say that sometimes it boggles my mind. I don't really understand everything that I'm seeing there. But I noticed there is one huge comet. That comet must be huge. And there's this huge tail coming off it.
McNaught.
And
I have that actually up here. It's, I tell you, you never can find this when you're really looking for it. It's like, well, I had it right here just a second ago.
And at the time, stereo B was very close to the Earth.
Yes.
It was still doing a loop around the Earth. And we see extremely strange things.
So go ahead.
I would expect that the solar system is full of these objects by now. Like I said, they started coming in like 200 years ago. They've been doing everything they can to hide what's going on since perhaps the 1970s, the 1980s. So all that they've built is to try and hide what they expected probably since 1980 to happen to the sun, which is that it would die.
So I just want to explain to everyone, these, as you can see, the date on this was September 2017. So what I've
there's
done,
an object, huge object there.
yes, we had, as you know, on September of this year, folks, of 2017, y'all remember that's when we had the X20 solar flare that went off. This is what was captured as a result.
Yeah, because as I have written before, these objects provoke the sun into having solar flares. And they do so when they first arrive. This object is absolutely huge. The sun would be, this object is like 20 times the size of the sun. Well, maybe 10 times, between 10 and 20 times the size of the sun.
Pulling up the next series of this. So everyone, here it goes again. Now, Claudia, this is in the positive, negative. So we know it's, look at that. Very well defined, whatever this object is. It's probably one of the better pictures of it right there. And look at what happens when that CME hits it.
Yeah, you can see what's coming from the sun, and you can actually see it hitting this object.
Yes. Look at the reactions up here. I mean, huge explosion. I don't know if that's an explosion. It looks to me to be having...
Yeah, don't forget what these objects are. They are expanded stellar cores, and they have material attached to it, which they shed. They lose that outer material. So when the sun hits it with a CME, you would expect more of that material to come out of it.
Yes.
So it sheds even more the moment they are close to the sun. And the sun will, of course, react to their presence. So we're seeing all of that here. That object is absolutely huge.
It's huge. It's and that's just...
You see, this is the type of object that should have turned into a black hole.
Now that's interesting.
Yeah, it should, but yet it's a solid object. Do you realize these are solid objects? I've shown through the blue stellar core that these are solid objects. But if these had been stars, then they should have, when they died, instead of expanding, they should have turned into black holes. Because that's what the standard theory says should happen. But the fact that we have this huge object in this image shows you that black holes do not happen. You cannot have a black hole or stars turning into black holes when you have this huge object in our solar system.
Now, this is the one, Claudia, and I actually sent you, I think, the raw video on this. And this is the one that the ISS captured. And let me...
Yeah, oh yes, this is, I think, you see this magenta light that it's emitting. I think this is actually the simulator that's in orbit. Look at the magenta light, look at the laser. This, I think what you have captured here is the actual simulator in orbit.
Interesting.
Yeah.
And here you can actually see it's rotating. It's...
Yeah.
Now, I hadn't thought about that, Claudia, that it was, potentially the...
Yeah, this is what it is. I think that's what it is. I can't be sure, but it doesn't look natural. Look at the thin laser beam. To me, the moment I see a laser beam, a straight laser beam, I don't expect it to come from a natural object. I expect it to come from a device.
By the way, that's that same color the sun I
Exactly.
captured. It's exactly the same color.
It's exactly the same color. So now you know what you saw there. This object, I think, is the projector, the holographic projector itself that projects the sun onto the clouds. So you would project the color that it's made of as well, I would think.
How interesting.
That magenta color from that sun there.
And then you can really see how, look at that. So it's just, how interesting. You know, they said 2018 was the year of purple. I guess it is. Well, there we go. Well, boy, another hour.
Already.
Come and gone. Wow. So what are you working on? You know, because
I'm working on an article on the alignment, because there's a lot of reports going on the planetary alignment, and they're saying, oh, all this volcanic activity must be due to the planetary alignment. I said, excuse me, but so I calculated the force that the planets exert on the Earth compared with the sun, and it's tiny. It's like Jupiter exerts a force of 0, and then 4 zeros, and then a 5.
Okay.
Of the force that the sun exerts on the Earth. So I do the calculations, or I did it for Mars and Venus. It's all tiny little values. Plus, you see, these objects, they exert a very weak gravitational force on the Earth. Plus, they are very far away. And so when objects are far away, they exert a force on the whole planet, on the planet as a whole. And you would need an object to come very close to the Earth to deform the crust, to cause this volcanic activity. And only an object that's very close can deform the crust, because then it pulls matter that's just underneath it, the crust, and doesn't pull the crust further out. That's a tidal force. That's how tidal forces work. That's why the moon causes the tides. So you pull on the crust here, you don't pull on the crust there. What happens? The crust deforms. That's what would cause this unprecedented volcanic activity we are seeing. It's tidal forces, not tiny gravitational forces from objects that are far away. So the only thing that can explain the volcanic eruptions is objects from outside the solar system coming very close to the Earth. That's the only thing that will explain the tidal effects that we are seeing as well. And now we're starting to see freak waves as well, which is the opposite, which is to be expected. But it's not the planets. It's just an excuse. Of course, the powers that be would like us to think that it's just the sun and it's just the planets that are causing everything, because they don't want us to know about these objects that have invaded our solar system.
Claudia, all right. I just want to say thank you to everyone who is giving donations. I mean, I'm just humbled by it. There's a question here. Dr. Albers, you mentioned it's easy to move in the atmosphere with electricity. Does it require superconductors, or is there an easier route? Love your work. And this is from Ed Loves 11.
Okay, no, you don't need superconductors. Superconductors can be used to shield gravity. Okay. In other words, they change the energy levels above them. And the energy levels are like the energy levels of an atom, where the electrons occupy certain energy levels. And when they absorb energy, they move to an upper energy level. They move further away from the nucleus. The Earth is the same thing. So you have the core of the Earth is like the nucleus of an atom. And in the atmosphere, you have energy levels for electrons. But it's not just 1 or 2 electrons. It's huge numbers of electrons that have the same energy. So the way you would navigate is you would have to have a metal surface. You would then push a current through it. And when you push a current through it, you get energy being absorbed and given off by the electrons on that surface. And that affects the electrons above the surface as well. And when that happens, you can navigate according to where you push the electrons towards, whether you cause them to lose energy or absorb energy from the atmosphere. So you always get propulsion in the direction of the positive electrode. So the anode. So you need, all you need is a very high electric potential difference, high enough to be higher than the energy of that energy level in the atmosphere. That's basically it. This is how electrogravitics works. Electrogravitics is just propulsion within the Earth's gravitational field, which is associated with energy levels, gravitational.
Could you take that outside the Earth's atmosphere? That seems to me like a propulsion system that...
Yeah, you can, but then you are navigating in the sun's gravitational field and electric potential.
Okay.
And so you would need even higher electric potentials to navigate in the sun's gravitational field. You can then take it outside of the solar system, but then you need even higher because now you're navigating in the galaxy's gravitational field.
We'll have to talk about in the next show or something on the whole theory of solar sails, of actually collecting photons as they would push potentially an object at near the speed of light.
Yeah, but you need it's
science fiction, but I mean,
time for them to reach high speeds.
It's the idea of how can we travel interstellarly? It's like, I keep on contending that the Earth, and I know this sounds kind of counterintuitive to where I've been brought up, but it seems like the Earth is isolated. We're isolated in a quadrant of space. I mean, our nearest neighbor is, 1,000 years away. I mean, it's like living on a block and your neighbor is actually in the next city.
Yeah, well, there is supposed to be a large distance between stars, but these are stars that are living stars. And what the stellar cores have shown us is that there are a lot of stars out there and planets that are not emitting light anymore. And so our galaxy is not as empty as it seems to be. It's just full of matter that's not necessarily emitting light.
So you know what I think when I hear that? Someone's going to run into something in the middle of the night and we're going to go, what the heck was that?
That's exactly what has happened to our solar system.
Well, and there is ample evidence for that. And wow. Again, fabulous. Listen, before we go, one of the things I saw yesterday, I watched the daily report coming from the USGA that's monitoring Fissure 8. And what's happening out there, Claudia, is it's unprecedented. They've never seen it. The flow yesterday was moving at 15 miles an hour. And now they're finding that the crater that was initially the crater of the volcano, that whole summit is collapsing. So there's tremendous forces. And now we know that there's a fissure that opened up over the weekend up in Yellowstone. And I don't know. Now we have a north side.
I think Yellowstone is going to start doing, it has started already. There's something going on with Yellowstone. It's to be expected. As I mentioned before, the fact that the Earth is expanding and fissuring will mean that magma will find ways new ways to the surface. And if you already have a volcano there, then as fissures open up, that lava reservoir will find ways to get to the surface. It's always under pressure. But I listened to something interesting the other day, and that was that the Russians made boreholes into the crust. They have managed to get further into the crust than anyone else. I think 1/3 of the way, but they couldn't go any further because when you get to about 10 kilometers or 15 kilometers below, it gets extremely hot and the rock is no longer solid, it's semi-solid. And that shows you, and this is not all the way through the crust, this is not in the mantle. This shows you that the mantle must be molten already. That means we have so much magma inside our planet that when this starts happening, the magma is going to find ways to the surface. And all the volcanoes will eventually be oozing lava.
Well, just
all of them. And plus, there will be more of them occurring here and there. So Yellowstone will start doing it one way or the other, sooner or later. And I think it's starting now.
Well, the Seattle Times would agree with you. The article today, everyone can go online and pull it up. They had an article running in their front page that the entire West Coast up there in the Washington, Oregon area, this is they're now measuring, it's being pushed inward. So we're seeing the subduction zones being pushed further eastward. To me, that's being set up at some point in time, Claudia, that energy has to be released. And I wonder if that's having a correlating effect with what we're seeing happening in Yellowstone.
Yeah, it's possible.
I don't know.
To tell you the truth, I think we're not actually getting a lot of very strong earthquakes.
No, in fact, we're getting very little.
And there's a good reason for that as well. And it correlates to what I've been saying. The Earth is not the same size, it's expanding. So as the Earth expands, you actually would expect less pressure on the fault zones because they're actually moving away from each other.
Yeah, we're well
realize that. This is the reason why you may be getting less earthquakes, less seismic activity, but we're still getting them.
Yes.
But most of the time, we're now getting them associated with volcanic activity, like at Yellowstone, for example. That's because the volcanic activity is blowing out of all proportion. And that's what we expect from an expanding Earth, a fissuring Earth. It's just breaking up and moving apart. And we would expect the seismic activity to possibly not be as bad as it used to be.
Well, I keep on contending, it's over a year now since we've had a 9-pointer. At some point in time, something's going to slip in.
Yeah, well, I mean, we can still get extremely strong earthquakes, but I definitely see the volcanic activity just increasing to an unprecedented rate now. And we're not seeing the same increase with earthquakes, although we can still get a very large one at any time. That's true.
Well, by the way, you're a part of the country. They just found another very large magma pocket underneath y'all. So
yes.
And London found it very interesting last Friday. They were very strong quake up there. I never thought that the British Isles were seismic actively, but apparently they are.
The Earth is changing. It's fissuring. It's breaking up. You cannot go by what has occurred in the last 20 years. Everything's changing. The planet is undergoing unprecedented changes.
That's why we have to stay tuned, folks. Next Monday night, we'll do another paper with Dr. Albers. That's why we're going to do this. Well, Dr. Albers, it's been an exciting time. Thank you.
Yes, thank you, Wayne.
Listen, you're the teacher here, and I'm just honored to have you. Thank you, everyone in the chat room. Y'all have just been great. We've had a full crowd in here, Claudia.
Good.
You've had a classroom of over 260 people.
Wow.
Yeah.
Well, I used to lecture to about that number. That was like my limit of comfort, to have 260 students in my lecture theater.
You heard that, folks. Now, when we start seeing it go over 260, we'll have to start passing out.
Yeah, but that was in one lecture theater. This is not the same.
No. Yeah, you have a worldwide theater now.
Yeah, because, I used to tune into my students. So I used to feel extremely drained after lecturing.
Well, here they're sending you all the good energy.
Yeah, that's wonderful.
They absolutely adore you, and we appreciate you so much. Someone wanted to know, is Planet X News going to go live?
Yeah, I think Scott is getting ready to do something.
Okay, well then I'm going to, by the way, we ought to get Scott back on and let's talk about some of this volcanic activity. Let's talk about the increase in the volcanoes, and let's see what, I think that would be a good show.
Mm-hmm. Yeah.
Okay.
Yeah. Okay.
All right. Well, everyone, thank you. I'll let you get over there with Scott. And everyone, thank you again for joining us. You make this show a success. And Dr. Albers, you're the one who comes and teaches us. And I thank you for that, for sharing your knowledge.
Well, thank you for giving me the opportunity to speak about my theories.
Hey, like I said, I'm just a hamster on the wheel. I'm just going, this is cool.
Okay, good.
All right. Well, give my best to Scott. Everyone, thank you for joining us. We'll see you again next week here. I'll let you go, Claudia, as well. And y'all be good, folks. We'll see you next week. Bye-bye.